Hello everyone, welcome back. Today I am here with the 16th part of this questionnaire, and in this part I will discuss some questions from cellular techniques. Let's get started. The first question is, which form of chromatography allows mixture of enantiomers to be resolved? Our options are normal phase liquid chromatography, affinity chromatography, covalent chromatography, or chiral chromatography. So its right answer is this chiral chromatography. Firstly, I will discuss about chromatography. So what is chromatography? It is derived from a Greek word which is chroma. Chroma means color, and graphene means to write. So in this process, we apply a mixture of compounds to be separated on stationary phase. इसमें दो फेज होते हैं, एक होता है मोबाइल फेज, अदर फेज इज द स्टेशनरी फेज दैट मे बी सॉलिड और लिक्विड, और एक हम इसमें यूज़ करते हैं प्योर सॉल्वेंट सच एज वाटर और एनी गैस दैट इज अलाउड टू मूव स्लोली ओवर द स्टेशनरी फेज. And this solvent carries the components separately as per their solubility in the pure solvent. तो उनकी एफिनिटी के बेसिस पे ये हम सेपरेट करते हैं कंपाउंड्स को, मिक्सचर्स को. सो दिस टेक्निक इज़ नोन एज क्रोमेटोग्राफी. इन केस ऑफ कायरल क्रोमेटोग्राफी, इसमें हम सेपरेट करते हैं ऑप्टिकल आइसोमर्स और एनेंशियमर्स को बाय हाई परफॉर्मेंस लिक्विड क्रोमेटोग्राफी दैट इज़ कॉल्ड HPLC. ये दो तरह का हो सकता है, दैट इज़ डायरेक्ट कायरल क्रोमेटोग्राफी और इनडायरेक्ट. इन इनडायरेक्ट मेथड जो कि बेस होता है ऑन द कोवेलेंट फॉर्मेशन ऑफ डायोस्टेरिमर्स by reaction with chiral derivatizing reagents such as the separation can be achieved with the use of chiral stationary phase and commonly used mobile phase जैसा कि और chromatography में होता है. With direct method, the chiral selector is included in the separation system by addition to the mobile phase or by immobilization of chiral selector to the stationary phase to produce chiral stationary phase. Basically हम इस chromatographic technique को use करते हैं ऑप्टिकल आइसोमर्स और एनेंशियमर्स को सेपरेट करने के लिए. इन एडिशन टू दिस, नॉर्मली जो क्रोमेटोग्राफी होती है, वी हैव डिफरेंट टाइप्स ऑफ क्रोमेटोग्राफी. दैट इज नॉन एज एडसॉर्प्शन क्रोमेटोग्राफी. देन वी हैव TLC, that is called thin layer chromatography. Then we have column chromatography, and next type is the partition chromatography. So ये different तरह की chromatographies हम use करते हैं to separate various mixture of compounds. The next question is, which solvent is used for preparation of organic compounds? Our options are, that is deuterated chloroform, then deuterated water, all of these. So its right answer is all of these. All of these solvents are used for the preparation of various organic compounds. Mostly this one, that is called deuterated chloroform, it is used in NMR, that is called nuclear magnetic resonance spectroscopy. इसमें हम इसे यूज़ करते हैं. So this deuterated chloroform and deuterated water, these are commonly used solvents in organic chemistry for various purposes, and the choice of solvent depends on the factors such as solubility, stability, reactivity, and NMR compatibility, among others. So this right answer is all of these. Next question is, the phenomenon of the mass and energy of the two particles are converted to two gamma rays emitted at 180 degree to each other is called as. Our options are Cherenkov effect, autoradiography, back-to-back emission, or scintillation. The exact term used for this statement is called as pair annihilation, but we can say this back-to-back emission is near about the right answer of this statement. So firstly, pair annihilation refers to the conversion of the mass and energy of two particles into two gamma rays emitted in opposite direction. So this is the exact answer to this statement, that is called pair annihilation. Next, we have this statement that is called Cherenkov effect. So Cherenkov radiation is a form of energy that we can perceive as blue glow emitted when the electrically charged particles that compose of atoms, that is electron and protons, are moving at speed faster than that of the light in a specific medium. तो जब जो particles हैं किसी भी atom के, that is electron protons, ये move करते हैं at a speed faster than that of the light in a specific medium is known as, that is called Cherenkov radiation. Next, we have autoradiography. Autoradiography is a photographic method used to detect radioactive materials among the radio-labeled proteins that are resolved by 2D. Then, since autoradiography energy is able to penetrate through the gel and onto the photographic film, so basically इसमें हम डिटेक्ट करते हैं रेडियोएक्टिव मटेरियल्स को, जिसमें हम लेवल कर सकते हैं किसी भी प्रोटीन्स को या फिर nucleic acids को with the help of radio labeled isotopes. Next statement is scintillation. So these are the rapid fluctuations in the phase and amplitude of the wave. This is the term related to wave. These are caused by local rapid variations in the refractive index of medium through which the wave is traversing. Scintillation is mainly caused by local variation of the ionospheric electron density. So this is the main reason for scintillation. Next, this back-to-back emission, which is the near-about answer of this statement. While it is not the precise scientific term for phenomenon, but it does capture the concept of two gamma rays being emitted in opposite directions, back-to-back, due to conversion of mass and energy of two particles. So the exact term used for this is pair annihilation. The next question is, a solution of a substance expressing the number of moles of substance in 1 cubic decimeter of solution is known as. Our options are molarity, molality, normality, or buffer solution. So its right answer is molarity. Molarity is also known as molar concentration. So molarity is defined as the number of moles of solute dissolved in 1 liter or 1 cubic decimeter. 1 cubic decimeter of solution. The unit of molarity is mole per liter or mole per cubic decimeter, or m. So number of moles of a substance can be found using the formula. So the formula used to calculate the molarity is equal to number of moles of solute divided by volume of solution in liters or cubic decimeter. So this is the formula that is used to calculate molarity. Molarity changes with temperature because volume changes with temperature. So जो molarity है वो temperature के साथ fluctuation show करता है because जो वॉल्यूम है वो चेंज होता है टेम्परेचर के साथ. सो मोलरिटी कैन बी एक्सप्रेस्ड इन वेरियस यूनिट्स लाइक वी हैव डेसीमोलर, सेमीमोलर, पेंटीमोलर, सेंटीमोलर एंड मिलीमोलर. नेक्स्ट स्टेटमेंट इज मोलरिटी. So molarity is defined as the number of moles of solute expressed in kg dissolved in 1 kg of solvent. Molarity has no unit. Molarity is better way of expressing the concentration than molarity because there is no term of volume of solvent is involved. The volume of the solvent depends on the temperature of the solvent. Thus, there is no effect of change of temperature on the molarity. Molarity can be calculated by this formula, that is molarity is equal to number of moles of solute dissolved divided by mass of solvent in kg. The next molarity is related to solubility, as that is molarity is equal to solubility into 10 divided by molecular mass of solute. So this is how this molarity is related to solubility. Next statement is normality. So normality is defined as the gram equivalent of solute dissolved in 1 liter or 1 cubic decimeter of the solution, and unit of molarity normality is n. This is normality is n. So normality is equal to molecular mass divided by equivalent mass of solute into molarity. So this is the formula by which we can calculate normality. A solution having normality equal to unity is called a normal solution. So a decinormal solution is equal to n by 10, that is 0.1 normal solution, or semi-normal solution is equal to n by 2, that is 0.5 normal solution. So normality into equivalent mass. The next question is, excess of stain is removed by washing stain section with glycerine of what percentage? So our options are 1 to 5%, 5 to 10%, 10 to 15%, or 15 to 20%. So its right answer is, the most probable correct answer is 1 to 5% glycerine solution. So 1 to 5% glycerine is commonly used as a clearing agent in histology and microscopy, and 1 to 5% solution is typically sufficient to remove excess stain from the stain section. So this is the right answer. This was all about for our today's discussion about these questions which are related to cellular techniques. I hope you will get some idea from this presentation. If you have any questions, queries, and any suggestions, you can give it in comment section. Thanks for watching. Have a great day.